Every day, AI models are being trained to recognize objects, understand language, detect diseases, and power smart devices. But there's a challenge. A model trained on one platform doesn't always work easily on another. So, how do companies deploy the same AI model across different devices and environments? The answer is ONNX. Machine learning models are usually created using frameworks such as PyTorch or TensorFlow. Each framework stores models differently. As a result, moving a model from one environment to another often requires additional engineering work. This creates friction between research and deployment. A simple way to think about ONNX is as a translator. Instead of every framework needing to understand every other framework, they can all communicate through a common language. ONNX acts as that language, making models easier to share and deploy. To understand ONNX, we first need to understand what a neural network actually is. A neural network is simply a sequence of mathematical operations. Data flows through layers, and each layer transforms the information until a prediction is produced. ONNX stores a model as something called a computation graph. In this graph, each node represents a mathematical operation such as a convolution, matrix multiplication, or activation function. The arrows show how information flows through the network. By storing the model as a graph rather than framework-specific code, ONNX makes the model portable. The workflow is straightforward. First, train a model using your preferred framework. Next, export the model into an ONNX file. Finally, load that ONNX model using ONNX Runtime and deploy it wherever you need. The training framework is no longer required for inference. ONNX Runtime can optimize how computations are executed. For example, several mathematical operations can be combined into a single optimized operation. This reduces memory movement and computational overhead, which can improve performance and lower latency. Imagine a recycling facility using AI to sort waste. Engineers train the model on a powerful workstation using PyTorch. However, the final system runs on a compact industrial computer attached to a conveyor belt. By exporting the model to ONNX, the same model can be deployed efficiently without installing the full training environment. Scientists and engineers use ONNX because it provides portability, reproducibility, and deployment flexibility. A single model can be shared across multiple hardware platforms while maintaining the same learned behavior. To summarize, ONNX stands for Open Neural Network Exchange. It provides a universal format for representing machine learning models. By converting models into a standard computation graph, ONNX helps bridge the gap between research and real-world deployment. As AI continues to expand into cloud computing, robotics, healthcare, manufacturing, and edge devices, ONNX is becoming one of the most important standards in modern artificial intelligence.